Okay, thank you for the kind introduction. I'm so happy to be here. Thanks to Lida and her team for inviting me. She asked me to say something about philosophical things. So I tried to look into the past, what I experienced through the last 40 years in production engineering. I have to disappoint you, I will not talk about machine learning and artificial intelligence, although Fraunhofer, of course, is working on these issues. But I would like to draw your attention to the domain where we apply artificial intelligence and machine learning, which is the factory. And you are sitting here, you will have to bridge the gap between the factory and the production engineers and the data scientists and so on. So we have already seen this in the first keynote presentation. And we still have to overcome these gaps, and this will be your task. And all the young people, I tell you, if you are an IT expert, talk to the people inside the factory, and the factory engineers, I say, talk to the people in the IT, and so they are two worlds. There is a clash of culture, and we see it every day when we go inside the factory. So if I start, yes, this was the introduction, so I will skip the disclaimer. The only thing I would like to say is where we come from. The business unit and the institute where I'm working comes from signal processing. So we have done this for decades. We collect data from sensors, from PLCs, from signals from other devices, and make it somehow available to the operators, to engineers, to production managers or whatever. So we are focused really on the machine, the PLCs and so on. So this is our background where we come from. Of course, we have started to work also on MES and manufacturing execution systems and so on. But our background is really signal processing. And this is still valid today. Although we have all these mighty tools, there is a source which we have to connect to the machines and the PLCs. And this is what I like to draw your attention to in the next slides. And of course, there is a new topic in manufacturing coming up, which has something to do with data exchange. Again, we need the signals from the machines, the PLCs, the sensors, and so on. And I brought, well, it's not philosophical, it is not statistically significant, it's only based on experience, what I brought to you.
Building modern machines, devices, cars, or even bicycles requires a complex manufacturing supply chain. You constantly need to vet and maintain your manufacturing network, which takes time, money, and effort. Ultimately, this distracts companies from doing what they do the best, building and manufacturing products. This is where Xometry comes in. We have built a massive manufacturing network of over 10,000 manufacturers globally and 2,000 manufacturing workshops in Europe. Xometry connects the people with big ideas to the manufacturers who can bring them to life. With our AI-powered instant quoting engine, you can get quotes for your prototypes and production parts in just a few clicks. You can choose from over 15 manufacturing processes and hundreds of material and finishing combinations. All you need to do is get your quote, place your order, and Xometry takes care of the rest. From selecting the most experienced and accessible manufacturer, to performing quality inspections according to the required industrial standards, and having the parts delivered to you with the most reliable delivery services. Xometry makes it easy for engineers and purchasers of both small and large companies to tap into global manufacturing capacity and create resilient supply chains. From prototypes to serial manufacturing, build your products easily with Xometry, where big ideas are built.
So this is one thing that is going on now in the manufacturing world, that the manufacturing process and the interface between the buyer and the seller is captured by these types of platforms. Xometry is only one example of this. And the value proposition, they capture, well, the customer order process, they capture even the process development, the process planning, the ramp-up of the machines. In some cases, the Xometry also delivers the machines. So the supplier has a Xometry credit card, and they can buy the machines supplied also then by Xometry. and will deliver it. And of course, the products then will be delivered to the customer. And Xometry is only one example. There is Spanflug, it's a German company. Of course, there are many more others. Haisol, a Chinese one. So this is going on at this moment in manufacturing. And they really have a good value proposition because they tell you, you don't have to care about your supplier. We care for it. We manage your supplier network. You don't have to care about quality. We do it because we measure it and so on. You don't have to care about, messing around with your supplier, calling him, what is the delivery date? Can you deliver faster? And so on. Not necessary. Everything is done by the platform. But do we really want the platform to occupy the customer-manufacturer interface? No. This is not what we want. We want the direct contact between the supplier and the customer. And do we want the platforms to store all the knowledge on processes, on manufacturing parameters and so on? No, this is not what we want. We want to have it federated because we are Europeans. These are our values. So the question is, how can we overcome this stuff? So this is one example of what is currently happening in the manufacturing world. And here is the second one.
Especially startups and businesses with lower budgets have to find creative ways to be able to compete and stay on top of their game. Hazer helps me to stay flexible and productive and ensures that I stay in control over my company's resources. How does it work? Fair, transparent, and simple. I only pay a small monthly fee and a rate per spindle hour. I simply choose the duration of the Pazer contract term and configure the M1 to correspond with my needs. The fixed monthly fee includes an all-around carefree package. After a quick credit and identity check, the order is placed. Once that's done, DMG Mori directly coordinates the delivery date with me. In order to stay in full control, my DMG Mori provides me with essential information such as the machine status and spindle hours. And the M1 is only the beginning. Soon I'll be able to order many more machines with Pazer. M1, designed for your profit.
So this is another business model that is now coming up. You don't longer have to buy the machine. You pay for the spindle hour. You pay per part. You pay per using the machine. It's not only that you don't buy the machine. You buy the use of the machine. You don't buy a drilling machine. You buy the holes, for example. And now the question is, do all these companies out there, the machine builders and the component builders, the spindle suppliers and so on, do they have to build their own platform and develop all this stuff on their own? The answer is no. Features and functionalities that are not relevant to competition, for example, the billing process and so on, we can develop collaboratively. So we do it together only once. And that is the birth of the idea of data spaces in manufacturing. Although I know that there are data spaces already around there in other domains, but in manufacturing, this is just starting right now. And data spaces are there for multilateral exchange of data that comes from the processes and is then be used, for example, for these types of business models. And the industrial motivation for these data spaces is that manufacturing platforms, or the idea of platforms in manufacturing, in machine building and so on, will be, that they will control a portion of the market. This will surely come. And they maybe they become also important hubs of knowledge because they are able to store the process parameters and the knowledge, the geometries and so on. And of course now we are also coming into these new business models like pay-per-use. And now the question is, can we develop something which is an alternative to this centralized? We don't want to have the data stored centralized. We want to keep it there where at their owners, always there where the data is generated. And there is one man I really like. He used to be a colleague of mine when I studied in Berlin. He used to be chairman of Matzak, and he also was an advisor to Shenyang Machine Corporation, and now he's somewhere else in China, and he says there is no way for Europe, it's not only Germany, there is no way for Europe to come back and conquer, you know, the low price segments of machine building or the middle price segments of machine building. No, we are all in the premium segment, and the only way to get back a good portion of the market is to build machines, but also services around it. We need these services, we need these IT technologies around the machines, and of course, to also to strengthen the cooperation with our customer. So this is what he's telling us, because he's very deeply involved in Chinese projects. He sees what is happening here. So very interesting statement. And that's the reason why the German Federal Ministry of Economics and Climate Action has launched a new program that is called Manufacturing X. And Manufacturing X is a program for projects of data spaces in manufacturing. The idea is to have a couple of lighthouse projects. That's why I'm leaving today, because tomorrow there is a meeting on one of these projects. And of course, we need also the Manufacturing X kernel. And this kernel, these basic services, this has to be developed and implemented only once, in cooperation between DMG Mori and Trumpf, in cooperation between Index and another machine tool supplier, and so on. So although they are competing, they develop these basic services together, because it's not relevant for the competition. Of course, we need also certification, operation and billing and so on, and we have to transfer it somehow to these thousands of small, medium-sized enterprise all over Europe that have something to do with manufacturing. So that's the idea of the program. We have a couple of use cases and use case clusters, which are they're dealing with supply chain transparency, for example, in tracking and tracing, or product carbon footprint and so on. But this is really, I would say, this is daily business. More important is the stuff to improve the processes, to predict quality from data that come from different manufacturers, that come from different suppliers, and to make something really new out of it. Of course, also product development is a part. Capabilities, which are some basic services based on, you know, Verwaltungsschale, asset administration shell. It's a typical German word, but it's already standardized, because it has something to do with the semantics that we generate, that we exchange the data between different companies. And of course, we also have to think about business models. And here is, and one thing that is really interesting is that if you talk to the IT people that are also part of the project, they have no idea what vertical data exchange means. They know, you know, horizontal data exchange is very simple. You have a component supplier he delivers a component to a car manufacturer, and there is, of course, they exchange data, very simple. But if we talk about this vertical exchange, that means really we have to take data from the machines and the sensors and so on, and use and during the that we gain during the phase of operations of the machine. This is, for some of the information technology people, this is really something new, because there is, you know, engineers, how they work, never touch a running system. We want the machine to stand alone. It has to work alone. No interface, no internet, no, you know, this buzzy stuff with information technology that we don't understand. We want the machines running. Don't disturb the machines. So this is still the mindset of the production of the people in manufacturing. So the idea is, of course, that we start with exchanging data as we always did it, on the level of the factory. But I'm convinced that in a couple of years, also components and machines will be able to exchange data. If you talk to Stefan Hoppe from the OPC Foundation, of course he will say this is already state of the art, but inside the factories this is still very difficult due to IT security reasons, of course, because nobody wants a component to exchange data and send something away, well, just without any control of the production manager and so on. But this will surely come. And there will be new business models, because if there is a small and medium-sized companies who has thousands of devices out there in the field, they will not be able to manage all these connections to their components. So that means that we need also, data brokers, a new type of companies who will be able to manage all these connections to the different types of pieces of equipment that are out there in the factories. But this is still future. So the conclusion of this is, there is, of course, global competition that we face. If you look to China, look to the US as well, there is high pressure on the European core industry, not on the automotive, only on the automotive business, but also on the machine builders and the manufacturers, maybe also through these types of platforms. We need new tools like ML and AI to improve the entire value chain, not only inside your factory, only on your little smart shop floor or in your machine, but also in the entire value chain. And of course, still, Industry 4.0, or however you call it, number it, 5.0 or whatever, there is still a clash of cultures because we have this deep gap between manufacturing people and the IT people. So let's take a look, this is my proposal, let's take a look at the history. What has happened in the last 40 years? What did they say, the fathers of factory planning and production technology? I have tried to figure out some generic wisdoms that I would like to share with you. So the first thing that I brought to you is there are 3 books on factory planning by Béla Aktelecki. He is a Hungarian engineer, and I had the pleasure to work with his people. He established a company in Berlin in the 1990s, and there were some colleagues who did not read the book, they lived the book. They know everything about, different types of processes, different types of factories, and so on. And the major point is, the purpose of a factory is still to earn money. It is not, sometimes today I have the impression that a factory seems to be something very representative. It has to be nice, of course it has to be nice, but the purpose is still, it has to make money. Quality, time and costs, these are the major drivers inside a factory. And if you plan a factory, so I had the pleasure to do it with our Karlsruhe research factory, and it is possible to be creative in the first phase of the factory planning, and the factory planning means, first of all, you start with the process. You don't start with the layout. You start with the process, because the process and what happens inside the factory, that is the core of the factory. Then you think about the capacities and the dimensions. So how many machines do I need? And then the very last step is the layout. So don't start with the layout. Don't mess around, shoveling the machines on the shop floor. Start with the processes and with the dimensions, and not for today's product spectrum, but for that of, well, let's say in 5 years or so. And if you realize a factory, there's no more creativity allowed, because this will mess you up. So the second book, or the second thing that I brought to you, and it was already mentioned. In the 1980s and 1990s, we were talking about computer-integrated manufacturing. But the hardware was too slow, but the ideas to connect everything on the shop floor, they were really good. And if you look inside our factories, there are many solutions that come from this time, from 1990s, COBOL and Fortran programs and so on, where you have these ERP systems and also MES systems and so on. And today it is very modern to talk about agility. In those times, we loved to do it like in the waterfall model. Because waterfall, it proved to work. And sometimes, you want to go to Mars, but probably you find yourself on the moon. The third one is that inspired us a lot when I was a young engineer was the book about the Toyota production system. Maybe you remember that in the 1990s or 1980s, there were lots of managers traveling to Japan, looking what they are doing, what is lean management, what is lean production all about, what can we learn, can we adapt it somehow? And it was a time when the automotive industry in Europe was not that competitive, because the Japanese, they figured out that they were doing better. So what is the lesson that we can learn? There may be new competitors, or there may be competitors out there that use different types of tools. Maybe Chinese competitors today are doing better. Okay. Lean production as a whole is still one of the most important tools, and you do it, of course, before you digitalize something, because if you digitalize a bad process, you have a digital bad process. Very simple. But another lesson is that we can catch up with this competitive disadvantage. Why don't we bring our factories in Europe to a position that they are competitive again with all these Chinese stuff that we see out there and where we are told that they are doing better? No, we can do. We still have very good prerequisites. There's another book that I really like that was launched in 2009 about, adaptivity. A factory has to be adaptive. A machine has to be adaptive. Modules on the machines, they have to be adaptive and have to have some interfaces where you quickly can exchange one module and exchange it by another one. So adaptivity for factories really seems to play a major role, and adaptivity also includes inside a factory not only hardware stuff but also software. Is our software really already adaptive? So if you plug in a new device, does it have the possibility to say, hello, here I am, and I have these values, this is what I bring to you, these are my abilities and the skills, and you can use me right away? This is my question to you. Which company, which factory is already able to do this? And if you imagine about, cyber-physical systems and Industry 4.0, we are talking about this like 15 years. Now, where are we today? So there's still a way to go, because in one of the Manufacturing X projects, we are still talking about the issue of connectivity. Now, how is that possible after 15 years? Then there is another one that came up in 2012. Of course, maybe you know it. It's the mother of all studies of cyber-physical systems. It was the starting point for Industry 4.0. And from this point of time, at least we see that software becomes the new driver for hardware-based products and their competitiveness in different domains, and not only in manufacturing, but also in smart health, smart city, smart medicine, smart everywhere. And these cyber-physical systems, of course, they foster new technologies, like self-awareness. We need machine learning. It fosters also adaptiveness and cooperative actions between the different devices on the shop floor, on self-organization. So in one of these projects, we are talking about, of course, also autonomous factories and self-organization devices that crawl around on the shop floor, and AGVs and so on. IT security is one technology that we need, and also this book, in the study, it also talks about business models and ecosystems. And we still have a good starting position because we have everything in Europe that is required for this type of Industry 4.0. We have machine builders, we have embedded systems, we have microelectronics. If you go to the Silicon Valley, you find only IT providers. There are almost no machine builders. There is almost no microelectronics. We have it here. Everything, all the ingredients that we need for Industry 4.0 or Industry 5.0 or however you name it, we have it in Europe. It's available, and we can try to figure out how it works together. There is one book that I really like. It's about time management. It really inspired me. You have to identify your life hats, and I tell you, you cannot wear more than 7. So if you play more roles, you try to get rid of some of them. Don't have more than 7. Of course, you have to find out your personal mission statement, not for your company, but for yourself. So what is your personal mission statement, and what could be mentioned on your tombstone or in a presentation or a talk that will be given at your funeral? Please think about it. It's a good idea to make sure who you are and where you come from, where you're going to. I had to learn that business meetings and private meetings, they have the same priority. Ask Miriam, she knows how I messed up meetings and meetings and meetings when we worked together. Because I had 2 different types of calendars, and I had my private meeting in one and the business meeting in one, and I think my secretary, she was really upset because she always has to change something. So the one message is just, it has the same priority, business and private, in your private life. And then, of course, I try to get rid of tasks that are only urgent but not impossible, not important. Sometimes it's not possible, but well, at the end of the day, it's a good advice. And as we are in a holy place, I brought another one, and this is what I experienced through the last 35 years. However nice tools we provide, we cannot take away the curse that is laid on our work. Because when we were thrown out, Adam and Eve were thrown out of paradise, the Lord says, well, there will be sweat, there will be thorns, there will be thistles, and whatever tools we provide and we give to our customers, it will never be possible to take away the curse. We have to bear it. So this is one, I really had to learn that. Very, very hard for me as an engineer, but okay, this is a learning that I took away. The second thing that I had to learn from this book is, don't tell your customer something that is not true. Because especially in this manufacturing world, it is so close, so small, you will met twice. Even if people change their business cards, in a couple of times I did it, and it was not a good idea. So it's really good to be wise as a serpent, but harmless as doves. This is really a good advice. And the third one is, I sometimes see it in my own organization now in Fraunhofer, that is compliance, very important. Rules, very important. No. People are more important than rules. People are more important than compliance. So in some cases, I know that we have to obey the rules, because if you go on the right and on the left-hand side of the street, it's not a good idea. But in some cases, it may be better for the result to think about, well, is this rule really necessary, or can we sometimes find a shortcut around it? So this is what I brought to you. Thank you so much for your attention. And now we are open for discussion. Thank you so much.